Hello and welcome everyone to the May 25th live stream Q&A. I hope you can see me and hear me well. Just let me know on the chat room if everything's good, and we'll get started in just a second. There's about a 30-second lag, so I'm just going to wait a bit. There's going to be a long pause. Make sure I can hear, you can hear me very well, and you can see me very well. So let me know in the chat room if that's okay. I see 4 people in the chat room right now. Paul, Faison, Anibal, Colin. Hello, everyone. Thank you for joining. All right. Wait a bit longer so you tell me that the video and sound is okay. Very good. Let's get going. First and highest voted question comes from Lee. The Binance rollback that was proposed, Binance said they considered rolling back the Bitcoin chain, but then decided against it. How on earth would that have even happened if they had decided to go that route? What would have happened? Would this just mean Binance launching a 51% attack? Yes, Lee. So that's basically what they were proposing. In order to roll back the chain, what it would require on Binance's side would be to persuade enough miners, 51% or more of the miners, to go back, pick a block before the withdrawals happened that was spending Binance coins and sending them to an attacker address, the withdrawals that were recorded on the blockchain. Pick a block before they happened, set that as the parent of the next block, and start mining from that point onwards. Now, imagine that they decided to do this a day after the attack. So at that point, they would have to persuade miners to go back 145 blocks, which would be, exactly one day, or some such amount, and start mining 145 blocks in the past, and then use their hashing power to overtake the 49% of miners, presumably, that would be mining from the current block, from the longest chain, and overtake them, and therefore cause a reorganization of the chain. And during this time, what they would do is they would deliberately mine a double spend transaction from Binance, spending all of the outputs that was stolen by the attacker to Binance addresses. And once that's in there, then the transaction from the attacker would not succeed, because those coins will have already been spent on the chain being mined by the miners trying to do the rollback. But think about it for a second. Like, a 51% is not actually enough. And part of the reason it's not enough is because at a rate of 1% advantage over the chain being mined by the 49%, they would only achieve a 1 block gain every day. So every 100 blocks, they'd catch up by 1 block. Now, think about this for a second. The attacker is the chain that the miners are trying with a 51% to remine, to reorganize, only has a 1% advantage over the one being mined by the rest of the miners at 49%. But it starts more than 145 blocks in the past. Let's say that Binance didn't manage to launch this attack for a day. At this point, gaining only 1% per day means only 1 block in 100. So as they mine block minus 145, the other 49% of the miners mine block 1, extending their chain by 1. Just about 10% faster. So after they've mined 100 blocks, they're still 45 behind, but the other chain has now mined 99 blocks also. And so they started 145 blocks behind, and 100 blocks later, they're 144 blocks behind. Another 100 blocks, they're 143 blocks behind. At that rate, it would take them 150 days almost to catch up, overtake, and rewrite the chain. That is a very, very long time, during which, if anything goes wrong, let's say just 1% of the miners abandon this effort and go to the other side, it's all over. All of that energy that they tried to put towards remining the chain, rolling it back, is wasted. Now, let's say that Binance managed to do this in a much shorter period of time. They acted very, very quickly, collaborated with the miners. Don't know how they would do that exactly. They'd have to figure out, perhaps by persuading pools to join them. But the pools may start losing miners. It's a very, very contentious act. And they did it within 5 blocks. Well, even in that case, it would still take a very, very significant effort to overtake the other chain, because they're still only 1% faster. They'd have to get an overwhelming number of miners on their side, and they'd have to do it very, very quickly for this to even be doable from a pure hashing perspective. Some people have suggested that one of the ways Binance might get miners to do this would be to bribe them. And of course, one way to bribe them is to make sure that the transaction that they introduce, which spends Binance's outputs back to Binance, carries very, very high fees. And therefore, the miners are incented. They're going to get paid off for this. And those fees would have to be more than the rewards of the blocks that the miners would be rolling back. So let's say they rolled back 5 blocks. Well, the fees they would have to pay to bribe the miners would have to be more than 60 Bitcoin. Because, you see, the miners can make 12.5 Bitcoin just by continuing to mine blocks on the normal chain. If they go back and try to roll back the chain, that energy is going to be wasted. Even if they win, presumably the 51% of miners who took this chance have already mined those blocks or participated in the mining of the blocks. They've already received a reward. If they go back and spend the energy twice, they're not receiving 2 rewards, because either one or the other chain is going to succeed. They're only going to get paid once, which means, as a result, that Binance would have to bribe them by the entire reward amount of however many blocks they're trying to overwrite, and then some, because they're doing something very risky, very, very risky, because if it fails, that's energy lost, and they're not going to get the reward from Binance because they don't mine the transaction that has the fees. And then there's another little wrinkle, because at any point in time, the attacker can add a bribe of their own. And the only way, the easy way to do that is simply to chain a transaction on top of the stolen funds that also pays a big fee to the miners. But here's the trick. The bribe from the attacker is much less risky, because all the miners have to do is not play the rollback game and just continue to mine the chain, which is a much less risky proposition because they're not spending any energy to go against consensus. And they'd be able to earn that reward with almost 100% certainty. And so at that moment in time, if they roll back the chain, they lose the attacker's bribe. But that's very risky. But if they don't roll back the chain, they get the attacker's bribe for much less risk, which means the attacker doesn't have to bribe them more than the block reward because they're not wasting energy, and doesn't have to bribe them more than Binance. In fact, has to bribe them a lot less because it's a much less risky proposition. So the bottom line here is, how would the proposed rollback work? It wouldn't. It's as simple as that. It wouldn't. It's too risky. It would take enormous coordination. It would have to be done immediately. And there's no way, in my mind, that Binance would be able to incentivize enough miners, once the miners understood that this could easily be thwarted by a simple bribe by the attacker that would cause them to waste all of that energy. It's not as easy as people think to attack the chain, even when you have motivation and hundreds of millions of dollars at stake. Let me check in the chat room, see if things are going well. Fantastic. Okay, my audio is a bit grainy. I apologize for that. Or maybe my video is a bit grainy. I'm in a rural location with not very good connectivity, so this is as good as it's going to get, unfortunately. I am getting a very high resolution, nice recording here, so when we play these back on YouTube, it's going to be nice and crisp for everybody, but unfortunately this viewing, the live viewing, is not as easy to stream. Santiago asks, what is Taproot, a code change designed to increase Bitcoin's privacy? I'd like to know more about the Taproot soft fork upgrade proposed by Pieter Wuille. How does it work, and what are its differences compared to zero-knowledge proofs or other approaches being explored, for example, by Ethereum? So Taproot is very different from a zero-knowledge proof. It's not really a direct privacy solution as zero-knowledge proofs are. What it does is it erases the distinction between a payment to a public key and a payment to a script. So at the moment on the Bitcoin blockchain, you can distinguish between payments to public keys or public key hashes, pay to PKH, as they're called, because they start with a 1. So 1 addresses are simple Bitcoin public key addresses, or double hashes of public keys. And addresses that start with a 3 are a script. Now, that might be a multisig, which is the most common example. A lot of people think that that's a multisig. It might be SegWit wrapped in a script, or it might be some other script, like, for example, a Lightning channel. But you can tell the difference between a script and a public key. What Taproot does is it erases that distinction. It makes all scripts and public key payments look the same when they're submitted on the network. And when you try to spend them, then you can either choose to spend with a public key or spend with a script. And not just a script, but actually a Merkle tree of multiple script clauses of which you only reveal 1. So you can either spend it as a public key with a regular signature, or you can spend it as by revealing part of a script that's in a Merkle tree. This is really interesting because it creates a situation where all payments look the same. You no longer distinguish between scripts and public keys. And there's a very interesting fact here that because of the way Schnorr signatures work, which is combined in this proposal, or which has been proposed simultaneously with Taproot, with Schnorr signatures you can do additive signatures. And what that means is, let's say you have a 3 of 3 multisig, and all 3 people agree to spend it. Well, in traditional terms, you would have to do a 3 of 3 multisig spend, which is a script presenting 3 public keys and 3 signatures for everybody to see. Everybody knows it's a 3 of 3. When you spend it, it's going to be very visible. But with Schnorr signatures, what you can do is you can take the 3 public keys, collaboratively join them together, essentially adding them together, and create a master public key, if you like, and then add all of the signatures together and create a master signature. So the 3 parties can sign the public key of their joint public keys with a signature that is their joint signature, and then it looks like a straightforward payment to a public key. You don't know it's a 3 of 3 multisig because they all agree to spend it. And there are many, many scripts in which you have various thresholds or conditions, but if all of the participants agree, you can just do a joint signature like that and make it look like a simple payment to a public key with a simple signature. So the combination of these Schnorr additive signatures and Taproot then makes it for very interesting obfuscation technology. It's not directly related. It's not a direct solution to privacy. It's an indirect solution to privacy. It allows you to do other things to enhance your privacy too. So that's a very exciting proposal. Another typical example here would be closing a Lightning channel and making a payment to the two participants. Now, Lightning channel is a 2 of 2 multisig. But in most cases, the two parties that are participating in the Lightning channel close it cooperatively. Well, instead of closing it with this massive script that says, here, this was a Lightning channel and we're exercising the cooperative close script, what they do is they just join their signatures, present it as a Taproot public key and a signature, and then it looks like somebody just spent that input with a regular signature to 2 addresses. And you can't even tell it's a Lightning channel. So that's what Taproot is. It's part of a bundle of proposals: Taproot, TapScript, which is an upgrade to the scripting language, and Schnorr signatures that have been proposed to be launched together. The BIPs were written by Pieter Wuille, but they actually are the effort of multiple developers. Pieter Wuille did the reference implementation to demonstrate how it would work. And if this would be a soft fork upgrade as SegWit v1. SegWit v0 was the one that was launched in August of 2017, the first version of SegWit. We always start indexing from 0 in this case. And the second version of SegWit would be SegWit v1, maybe launched in the next couple of years, would be something along the lines of Taproot, TapScript, and Schnorr signatures. Now, on the side, if you're interested in hearing more about that, we just recorded a great podcast with Let's Talk Bitcoin with guests Jonas Snick and Pieter Wuille, and we talked extensively about what Taproot is, what TapScript is, what Schnorr is, and the impact these proposals will have on both scaling and privacy. You can catch that in episodes 400 and 401 of the Let's Talk Bitcoin podcast. We won't put that in the Q&A, but for the people watching the live, you might enjoy listening to those a lot more. We spent an hour talking about this topic. Some more privacy questions, and I'm really excited that we keep getting privacy questions. This is a really important thing for me. Quinn Solo asks, do you think there is potential for companies and exchanges to blacklist all CoinJoins Bitcoin? I hope one day Bitcoin will include a full privacy solution on the base layer, but until then, CoinJoins seems to be the best way to achieve reasonable privacy when purchasing BTC through an exchange or some other place where they have KYC. Most of my coins have been mixed and put back into cold storage using Wasabi Wallet. And Wasabi Wallet is one of the wallets that has a built-in CoinJoin capability. Do you think there's a possibility of not being able to sell or spend those Satoshis due to them being tainted? This is a great question. Now, the type of CoinJoin that Wasabi does is what's known as an equal output CoinJoin, where all of the participants are mixing with the same output amounts, which is one of the most effective types of CoinJoin because it's impossible to unravel after several rounds. Not impossible. It's extremely difficult to unravel after several rounds of CoinJoin. But, you know, there's an interesting thing here, which is, what exactly is a CoinJoin transaction, and how does it look on the blockchain? A CoinJoin transaction is basically a transaction where multiple parties join together. So it's a transaction where it's not one person making the transaction. It's multiple people signing a whole bunch of inputs that belong to multiple people and creating a whole bunch of outputs in the transaction that belong to multiple people. That's all it is. There's no one implementation of CoinJoin. In fact, there are several and have been several implementations of CoinJoin, several implementations of transactions with multiple people joining together to spend Bitcoin in a way that's more difficult to track. Now, if you have a transaction with 2 inputs and 2 outputs, is that a CoinJoin transaction? Not necessarily. It could be a transaction from my wallet that pays someone and then takes some change. And if the payment and the change are the same amount, again, that doesn't tell you it's a CoinJoin. What if there's 3 inputs and 3 outputs? Well, maybe that looks a bit more like a CoinJoin. What if it's 10 inputs and 10 outputs? That kind of looks again like a CoinJoin, but it's also the kind of transaction I would do to run payroll in my company when I have to pay 10 employees in Bitcoin, and I'm not going to do that in 10 different transactions. I'm going to do it in one. So that's not a CoinJoin, but it might look like a CoinJoin. And how would exchanges really know if it is or isn't a CoinJoin? I guess they could do some kind of heuristic. And then they're going to catch a lot of people who are not doing CoinJoin transactions, and they're going to have some real problems if they start tainting coins that way, especially if people start structuring their wallets to make more CoinJoin transactions or make more transactions look like CoinJoin. And then, of course, what if you did CoinJoin in the past, and then they decide to change how they treat coins, and they tell you, oh, no, those coins are tainted? Well, what does tainted mean? Tainted means that at some point in the last K number of transactions, those coins were involved in a CoinJoin. What value are you going to give to that number K? So how many hops or how many previous transactions are you going to look at? If you look back more than a dozen transactions, you're going to run into something that's tainted, which means that you can't go that far back. If you're an exchange, you can't blacklist after 12 normal transactions because the 13th transaction in the past was a CoinJoin. So if you have CoinJoined coins, all you have to do is do 13 consecutive transactions to yourself, regular transactions where you just bounce them from address to address to address to address to address, and then they're no longer tainted. In general, when it comes to tainted coins, this mostly catches those who are unaware of these situations involving with exchanges, because no matter how many hops they look back, all you have to do is, if they look at K hops back, you jump K plus 1. You create K plus 1 transactions to yourself, creating K plus 1 addresses, and the last one isn't tainted because the last K are not tainted. K plus 1 is tainted, but they're not looking that far back. And if they keep increasing K, eventually they reach a point where everything's tainted, and they can't use that heuristic because then they have to shut down their exchange. So, and how much does it cost you to make a new transaction with a new address? Remind me. Oh, right, just a transaction fee. And you can do that whenever you want. You can do it when the network is really, really low capacity. In fact, you're not in a hurry. You're sending from your own address to your own address. How much in a hurry are you? I can wait 200 blocks for a transaction like that to go through. I'm going to minimize the fee, so it's not that expensive to do. Of course, you have to pay the computational fee for creating a new address, which is 0. So this whole idea of companies and exchanges blacklisting CoinJoin BTC very quickly runs into some serious practical problems. And that will only drive an arms race. If they do this, then wallets will keep adding hops. For example, there are wallets today that add hops. One of them is Samurai, that does something called ricochet. You can say how many hops you want to add, and it bounces your coins from address to address to address and then sends them, so as to distance yourself from any tainting that has happened in the past. More wallets will do that, and more wallets will do more stealthy forms of CoinJoin to avoid any problems with exchanges. I think you're okay, Quinsato. Your coins are probably fine. I don't think you're ever going to see a situation where you can't spend them or make them clean enough to spend them with a bit of effort. All right, we have a question from the audience in the chat room. Do you travel with that backdrop? No, that's a curtain. It's a curtain. I stretched it out a bit. And yes, I do not travel with a beige curtain. But now that you say it, maybe I should. I do have a new green screen that I'm going to be trying in future episodes. We'll see how it goes in the live stream or Q&A. That would give me more options for remixing the background with something more fancy. And then, you know, I could be on set of Star Wars, or no, I can't do that. That's copyrighted. But I could do something similar. All right. Let me just see which question we're going to answer next. Here we go. How do colored coins work? I've been following the Bisq decentralized exchange and organization experiment. They're using colored coins on the Bitcoin network to incentivize traders, contributors, and arbitrators. I understand how colored coins work at a very high level, but I haven't found a good technical explanation about how it's implemented. Can you explain how colored coins really work? There's a chapter in Advanced Transactions in Mastering Bitcoin, which you can find, of course, for free on GitHub, that explains how colored coins really work. But the thing is, colored coins is not a specific technology. It's a concept. And it's implemented in a number of different ways. There are a number of implementations that implement the concept of colored coins. The idea of colored coins is really simple. You take a very small amount of Bitcoin, usually in the thousands of Satoshis, which doesn't have any real monetary value. And what you do is you mark it in some way that can be recognized by a specially configured wallet, so that that information can be tracked forward through transactions, and you mark it as having special meaning in addition to its monetary value. In practical terms, think of me taking a dollar bill and stamping on this. This is redeemable for 1 copy of Mastering Bitcoin with a little rubber stamp. It's still worth $1 if you spend it at the grocery store, but now it's worth, well, $34 if you get a free copy of Mastering Bitcoin from a bookstore that's participating in my colored dollar scheme. And so, of course, the stamp would be orange because that's the Bitcoin color. Now, that's an example of a practical example of the colored coin concept. The underlying currency still has the same value, but that value is really small, or really small relative to the thing I've stamped on it. And you need that because otherwise people will spend it to buy gum, and then it's lost in circulation and people don't know that it's special. But the thing that's stamped on it can be stamped in a number of ways. And there's a number of protocol implementations of colored coins. Some use special public key addresses that mean something. Some use special multi-sig addresses that mean something. Essentially, they construct scripts or put information into a transaction. So when you initialize a colored coin, what you do is you first stamp all of the Satoshis. And then from that transaction, which is the genesis transaction of the colored coin, you can then spend small amounts with additional Bitcoin transactions. And a wallet that's configured correctly can trace back to the transaction where you created the colored coin and see what kind of colored coin is. Now, one of the easier ways to do that is using the op return script operand. And what the op return script operand does is it allows you to introduce, I believe, 80 bytes of information as an output in a transaction. And that 80 bytes could be a hash, or it could be a binary encoded message that can be read by a wallet that's configured to read it. And one of the colored coin protocols does exactly that. So you have an op return followed by a special code that says, hey, this is the colored coin protocol, followed by, and this coin is marked in this way with so many units that are divisible in this way, and here's a URL that tells you how to look it up. And based on that information, a wallet can display interesting things about it, a name, for example, maybe even an icon for that colored coin, and then know how to spend it in a way that maintains that information going forward. So that's how colored coins work in this particular case. There's some implementation details, like what does the wallet put in the op return? How does it encode that information? There's a whole specification you can read on different forms of colored coin implementations that tells you how the information is encoded. And if you want, you can go and look in the blockchain at a raw transaction that created a colored coin, use the colored coin wallet to create a colored coin, and then go in the blockchain and look at that transaction, and look at the raw data in it. And you should be able to unravel it and say, oh, right, so this is the little encoding that they're using, and it matches the specification. You can read it, essentially, by unraveling the hex or binary encoding. All right. So that's how colored coins work. Michael asks, where are Satoshi's Bitcoin? Oh, that's a really simple question. They're right here. I put them in my right pocket. Oh, no, I didn't. I'm not Satoshi. Let's try that one again. Michael asks, where are Satoshi's Bitcoin? You've said that Satoshi themselves has likely mined 1 million Bitcoin in the early days of Bitcoin. We don't know exactly how many. We can't know because they just went to specific addresses. People have estimated different amounts, but it's a pretty big amount. Is it possible to track these wallets? Well, you can't really tell which ones are Satoshi's because within a short period of time, other people were mining too. But you can track some of them, and that's certainly the case. Is there a fear that they could be used to control Bitcoin or hurt the price? Some people say that since they haven't been touched in 10 years, they never will be touched, but that seems foolish. And there's a follow-up question from Ricardo. I believe that at some point the cryptography securing Bitcoin right now will be broken. Quantum computers is one example. It won't happen overnight. Will there be a period of grace where all holders will have a chance of moving their money to new address schemes? And how do you think the community would react? Would you be in favor of a protocol change that invalidates the spending of vulnerable funds if they're not moved by a certain pre-agreed date? All right, let's start from the beginning then. It is possible that if a very large amount of this Bitcoin started moving and started getting liquidated on exchanges, that would hurt Bitcoin's price. Long-term, probably not. Short-term, it would be a surprise to a lot of people and cause a big ruckus in the market just because people are react to news like that. In the long term, if Satoshi spent these coins, I hope Satoshi would buy some nice things, you know, a small island, small nation state, and spend them wisely. But who knows? Nobody knows what might happen. In the long run, effectively, spending these coins would redistribute them into the economy. And any form of spending would be a form of investment where these would be invested in various things that you can buy with Bitcoin. Now, obviously, it would be bad if Satoshi decided to dump it all for dollars and not hodl or buy something or invest in companies in the Bitcoin space. I think that's unlikely, but who knows? So that's a lot of speculation. We can't tell how many coins there are. We don't know what they might be spent on. We don't know if Satoshi is alive or not, and if alive, if they have access to the keys or the keys have been lost or deliberately destroyed. So a lot of people claiming to be Satoshi, of course, as always, and this is a lot of drama that really doesn't matter. What's going to happen to the price? I can't tell you. A lot of volatility probably, especially in the short term. They haven't moved. That we do know, because if they did move, we would see it in the news very, very quickly. So people would notice some of those coins from the original blocks moving. Now, to the second part of the question, or the follow-up question, would I favor a protocol change that invalidates the spending of vulnerable funds if some kind of development like quantum computing or a vulnerability in the way digital signatures work could take money without owning the original keys? Like if other people could use quantum computing or a vulnerability to take the original coins and spend them, would I be in favor of a protocol change that invalidates the spending of vulnerable funds? This is a really difficult and controversial decision. First of all, I would not express an opinion. Honestly, I wouldn't. Because I think the responsibility that comes with that, especially if people tend to listen to you, is too great. I would shut up and pay attention to what other people are saying and maybe listen to the discussions. But I think a protocol change like that is dangerous for a number of reasons. One is, how do you discern between vulnerable and not vulnerable funds? How long is long enough that these funds haven't moved? How do you discern between funds that are in a retirement fund that are sitting for decades versus funds that the keys have been lost, versus funds that somebody doesn't want to move for a variety of reasons, maybe because they're in a compromised position? And can you just take them? And take them and do what with them? Invalidate spending them? That's stealing, effectively. Or redistributing them? Again, that's stealing. Even if you just invalidate the spending, then you are effectively redistributing that value to everybody else, because once you have reduced the initial supply of Bitcoin in a known way, we know some Bitcoin's lost, but we don't know how much. If we knew exactly how much is lost, then we would have a very good idea of the remaining supply. And if you invalidate what you're saying is you're picking a number there, that would have an impact on price, effectively redistributing that value to everybody who has the remaining keys. So that's tricky. Putting a deadline and saying if you don't move your coins by then you lose them is the kind of centrally managed behavior that you see in traditional economics. Changing the rules to implement that would be enormously controversial. I don't think it would have consensus at all. I think simply the controversy of this would cause paralysis. I don't think there's any way anybody would be able to pass a change like this with enough consensus. And if there isn't enough consensus, what happens? The status quo remains. This is one of the main characteristics of Bitcoin. The reason it's sound money, the reason you can depend on it, the reason it is controlled by algorithm is because changing the algorithm requires consensus. And if there isn't enough consensus, the algorithm doesn't change, so it remains the same. And that means you can't do this. I don't think you would ever get enough consensus to do anything like this, because it would affect a lot of people's long-term trust in the stability of the protocol. Even much less controversial changes have not been able to achieve consensus. This is certainly way high. So what would likely happen? What would likely happen is that quantum computers at some point will be able to steal Satoshi's original coins if they haven't been spent or moved by that time. And great. Well, that's a good reason to invest in quantum computers. And it rewards the people who invest in quantum computers with a nice bounty of unmoved Bitcoin that hasn't been protected by better signature technologies. That's a much better solution because it's technological, it's market-based, and it rewards the people who invest in superior technology. You're more likely to see that happen in status quo. All right, let me check in the chat room, see how things are going. Guy asks, how does one keep Lightning channels balanced? I noticed one of my channels got used up quickly. This is a very, very big topic, which is being discussed quite a lot in a number of different circles. It depends, and the answer will change over time as the protocol and the clients develop. The simple answer is you close the channel and open a new one that's balanced. That's the simple channel. That's the simple answer. You can always do that. Of course, that means you're going to have to pay an on-chain fee, but you're not in a hurry. You can pay an on-chain fee that's pretty low and wait for that transaction to settle. It's not a huge deal. Now, what does it mean, first of all, for a channel to get used up? With a channel, a Lightning channel, you have two balances, not just one. The capacity of the channel is determined by two numbers, and that's how many Satoshis are sitting on one side of the channel and how many Satoshis are sitting on the other. If I'm in a bar, the example I usually use is I take two of the bowls of peanuts that that the friendly bar people have given us, and I say, okay, these are the two ends of the channel. So to move money from this side to this side, you basically take some peanuts from here and you put them in the other bowl. And you can keep doing that as long as there's peanuts in that bowl. Once you've moved all of the peanuts to the other bowl, now your channel is unbalanced. Why? You can't move in that direction anymore. But you can move in the other direction. So as long as you send payments back, then you can rebalance the channel without closing it. And so there's two ways of doing that. Let's say, for example, that you have incoming payments that are paying you, and the channel that you're relying on for incoming payments that has a lot of balance on the other side ends up with all of the peanuts on your side. Okay, so you've earned some peanuts. That's great. You're making money. Essentially, you're selling something or you're offering a service, and people are sending you payments, and all of the balance ends up on your end. You've made some money. Well, one way to rebalance the channel is to spend some of that money. So if you make a Lightning payment to buy something, or deposit into an exchange to get some fiat or something else, or you buy something from a store that's Lightning enabled, that will move some of the Satoshis from your side to the other side. Satoshis are peanuts, if you remember my previous analogy. And so what that will do is, once those have moved to the other side, they're now available again to make payments into you. So that's another way to rebalance it. There's a whole lot of other schemes that you can imagine here. One of them is to make a circular payment, which can benefit you, but the net result for the network is the same. So let's say I have two channels. I have my left channel here and my right channel there. And the left channel has become unbalanced, and there's Satoshis on this end. Well, one of the things I can do is I can give myself an invoice and then route it so that it leaves this way, goes around, and comes back this way. So what that will do is it will move some Satoshis from me to the other side of the channel here, and move some Satoshis from the other channel over here to me again, closing the circle. The problem is that that's also going to do is move the Satoshis on everybody else's channels who you use to route between these two channels you're connected to. And that may be unbalancing them, which means they may decide to try to move something in the other direction. The net for the entire network isn't balancing. To do that, you have to open new channels. But it does solve your problem. And so if other people are very well balanced and you're not, you can become more balanced yourself by making other people slightly less balanced. And so the circle of life continues. There are other techniques which involve using the opportunity of an on-chain regular Bitcoin payment to close and open a channel. And these are various techniques called splice in and splice out, or loop in and loop out. So imagine you have a payment that you're going to do to a merchant on-chain. You're going to do a regular Bitcoin payment. Well, it has some inputs, it has some outputs. You can use the opportunity of that transaction, since you're already going to pay a fee, to also close and open a channel. Because closing and opening a channel is a transaction. It has inputs and outputs. And you can mix transactions that close and open channels with transactions that make a Bitcoin payment, and make them one transaction which has all of the inputs, which are the money you're spending to make the payment, and the channels you're closing. And the outputs are the money going to the merchant on-chain and the channel you're opening. So you use the opportunity. When you make an on-chain payment, you rebalance your channels. I think in the long run, you will never make an on-chain payment without your wallet also using the opportunity to close channels that need closing, open channels that need opening, and therefore reduce your overall fees, because a transaction with more inputs and outputs costs less than more transactions. And there are other techniques that can be used, including persuading other people to open channels to you. So there's lots of ideas around this, and this is still early days. We'll see how it goes. The next question comes from Anibal. Bitcoin and privacy proposals at the core layer. Hello, Andreas. Could you please summarize the most relevant proposals regarding increased privacy at the Bitcoin core layer? At least name and simple description of each one. Thanks in advance. So there are many different proposals, and they address different aspects of privacy. Privacy isn't something you only do in one layer. Privacy is something you do in a variety of different ways. So let's start with the core transaction aspect of Bitcoin. When you're doing a Bitcoin transaction, you reveal a lot of information in terms of the inputs, outputs, and values, right? So one way to do that is to mix lots of inputs and outputs, and that's CoinJoin. You can mix inputs and outputs with other people. Another way to do that is a two-party payment swap, which is where if I want to do a transaction and Bob wants to do a transaction, we do a very simple swap where I pay Bob's recipient and Bob pays mine, effectively swapping our coins out for each other. And that really messes things up because suddenly it looks like my coins were actually Bob's and Bob's coin were actually mine. Imagine a scenario, for example, where Bob wants to buy a widget from a website. They want to buy some chewing gum online. And I want to buy a whistle. But both of the vendors are going to take address information to ship us the whistle and the chewing gum. And they're going to use that address and identity information in a way that's going to reveal to other parties and link it to real-life identity. And perhaps we got the coins from exchanges, and those linked the original coins to our real-life identity. Well, imagine how annoying it is to the analytics company if I buy Bob's chewing gum and Bob buys my whistle. Now they see coins that they sold to Bob on an exchange that gave them surveillance information, buying a whistle that's being shipped to someone else, and vice versa. Now they're really confused. You basically are messing up the data set. Confidential transactions is a proposal to do encryption of the values of the outputs. And what this does is it makes CoinJoin more effective because the main way you can statistically analyze CoinJoin is through the values. And so if all of the values are encrypted and you don't know what value is being transmitted, then that makes it much more efficient to do CoinJoin and much less efficient to do analysis on that. So it's something that you combine with another privacy technique. Confidential transactions is essentially a zero-knowledge range proof that says these outputs are within add up correctly to the inputs, but we don't know what they are. So they're encrypted values. So that's confidential transactions. Then there's a whole lot of other things that are required in order to gain privacy. One of them is the kind of fingerprint that your wallet leaves. Wallets can do various things that are very harmful to privacy. For example, many naive wallets always put the change transaction last. Well, the change output last. Well, if they put the change output last, then you always know which output is change, which means you know that the other one or other ones are payments. And that reveals far too much information. So there are techniques to avoid that. One of the techniques is to simply sort the outputs by the address. So basically almost like alphabetically sorting the address. So the first output is always the one that has the address that starts with the lowest prefix. And the last output is always the one that has the highest prefix on the address. And if you've lexicographically sorted the addresses, it gives you no information about which one is payment and which one is change. There's other things about how wallets set various parameters in the transaction. So some wallets, for example, set the time lock in the transaction to avoid fee sniping. If you do that in a very specific way, that leaves a signature. So if you're using certain types of wallets, they can leave little fingerprints behind that are very characteristic of that wallet and how it implements certain things. So having standardization where wallets do things in the same way, produce transactions in the same way, reduces the ability to identify what type of wallet it is. Like, you can't see the difference between an Electrum wallet or a Trezor wallet or a Wasabi wallet or a Samurai wallet or whatever else you're talking about, a bread wallet. And that's another technique that's really important for privacy. Another element of privacy is how you route transactions when your wallet prepares them and then wants to transmit them on the Bitcoin network, which is if you simply give them to one of the nodes you're directly connected as a peer, and that node transmits it to all its peers, and that node transmits it to all its peers, and you flood it out, which is the traditional way of flooding transactions out. If an attacker has enough nodes in the network, they can triangulate the origin of the transaction, and then they can deduce information about geography, for example, or even pinpoint the specific IP address, which was the first one to see the transaction, and use that to find out which node it came from, which could reveal a lot of information. A technique to overcome that is called dandelion. Now, imagine a dandelion that is being blown by the wind, and then at some random time it breaks open and all of the little seeds fly away. That's the image for dandelion routing. In dandelion routing, what you do is you basically onion route a transaction to some node out there without flooding and sending it to anybody else. And then when it reaches that intermediate node, it puffs out and floods from there. So if someone was triangulated, they'd find it came from there, but they don't know if it really did come from there or if it was dandelion routed. So again, that's another technique to avoid being tracked. Another technique to avoid being tracked is, of course, using the onion router network, Tor, in order to both connect your node to other nodes, as well as do transactions with your node, or even connect your wallet to your node if your wallet is not running on your node, using your own node instead of an SPV wallet or some other lightweight client, and certainly not using a third-party custodial service. So again, privacy is something you use in layers, and you need to apply several layers of privacy in order to achieve a high degree of privacy, and it's never perfect. It's never perfect. There is no silver bullet. It's an arms race. Like any aspect of information security, you do more things to do privacy. The analytics and surveillance companies do more things to violate your privacy. And if you do things well enough, and enough people do things well enough, we start winning. We start winning our privacy because it becomes very difficult for the analytics company to really pin down the information they need to. A lot of the information is tainted. All right, let's see. I think we've got time for one more question. GlobalCoin. Mark asks, hey, Andreas, it's official. Facebook is giving us GlobalCoin early next year. Please put all our concerns to rest and remind us why this will only compete against central banks and fiat currency and not be a threat to Bitcoin. Thanks. Unfortunately, I can't put your concerns to rest. In fact, I've sold all my Bitcoin in order to buy GlobalCoin. No, I'm just kidding. Fundamentally, the thing to understand here is that what Facebook or any company like Facebook is proposing is not a cryptocurrency. It doesn't have any of the fundamental characteristics of cryptocurrency. It doesn't stand on the 5 pillars of an open blockchain. In fact, it has none of those. So what are the 5 pillars that we talked about before? You've probably heard this a few times. An open public cryptocurrency is open, it's public, it's neutral, it's borderless, and it's censorship resistant. And all of these things are characteristics that stem from decentralization of control. Anything that's created by a centralized organization, any centralized organization that can be identified, that exists in a specific jurisdiction, that is subject to specific laws, cannot achieve any of these 5 pillars. And the reason they cannot achieve is because the law prevents them from doing so. So first of all, they can't be censorship resistant. Let's start from the end. They can't be censorship resistant because they are legally required to prevent the transmission of funds to certain entities. These entities include sanctioned countries like Iran, North Korea, Venezuela, etc. These include sanctioned entities that are people, companies and people, those listed, for example, on the OFAC list that's run by the US Department of Treasury. You can't send money. If you can actually go find the OFAC list, Google search it. It's a search engine. You can type in a name and they can tell you if that name is on the OFAC list. Just for fun, type Pablo. Number one name that's going to come up is Pablo Escobar. And you are not allowed. In fact, it is a felony to send money to Pablo Escobar. And that list is long. How long? Nobody knows because it's a secret list. And that list is something you are required, if you're a regulated entity, to check against before transmitting payments. So it can't be censorship resistant. In fact, you're required by law to censor certain transactions. And these transactions, that list is getting longer and longer and longer. So if it can't be censorship resistant, it also can't be borderless, because you're prohibited from sending money to certain countries, which means that you have to be able to identify both who is receiving this money and where they are. In order to identify who and where they are, you have to do know your customer, anti-money laundering, counter-terrorist financing regulations. Essentially, you start behaving like a bank. Anybody who implements a payment system that's centralized has to follow all of the rules of a money transmitter or bank. At that point, you're no longer neutral. The protocol itself cannot be neutral, because neutrality means any sender, any recipient, any value, regardless. And the protocol does not care where you are, who you are, what you're doing with that money, and why. And a regulated entity cannot not care about all of those questions. They have to check all of those things. Who are you? Where are you? What are you doing with that money? And where did it come from? And you may notice those are very specific questions. You've probably recognized your bank has probably asked you some of these questions. One of the exchanges you're dealing with has probably asked you some of these questions. What is your income? Show us your ID. Which country are you in? Are you an American? Et cetera, et cetera. So, and this applies across the world. And every jurisdiction has different rules, which means that you can't be borderless in another way. Facebook operates as a borderless company in many aspects of its operation. Money is not one in which it can do that. It can do that with content through various protections of the law. And even that results in Facebook being blocked and banned in a number of authoritarian countries. But to try and follow the payment regulations for 2 billion customers who are split in 194 countries is a morass. And it would result in the same kind of problems that PayPal has. Why is PayPal not a global company that serves 194 countries equally? Because they can only serve 20 or 30 countries equally. And even there, they have to do all of these things because they became a bank. They're not censorship resistant. They're not borderless. They're not neutral. And they can't be public either. Because they can't make all of this information publicly available, because that would violate various laws. Now they've got a lot of privately identifiable information about owners of money. They can't make any of that available publicly. They can't create public APIs. They can't create public transparency reports. They can't do any of that because of all of the laws that apply to the secrecy of financial information. And as a result, most importantly, they cannot be open. They cannot give you access to this to send it or receive it outside of their platform. They cannot allow you to extract it from their platform. They cannot allow you to sell it to someone else without them being an intermediary. They will have to sit in the middle and control every transaction. They're not open. They're not public. They're not neutral. They're not borderless. They're not censorship resistant. They're not a cryptocurrency. They're a bank. They're a bank just like PayPal and JP Morgan Chase. Now, they're going to be a very large, multinational, very powerful bank with a lot of users. So banks should be really scared, because when technology companies start playing in banking and they have all of these users and all of this experience in technology, that creates some real challenges for banks. Because even though Facebook cannot be as open, as borderless, as neutral, as censorship resistant as their cryptocurrency, they can certainly be more open, more borderless, and reach more countries than JP Morgan Chase. And they start off with more users. So that should be scary for all of the existing financial services companies. It should also be scary for some authoritarian regimes that will try and fail to block Facebook, and then try legal shenanigans and, again, probably fail, or face an army of lawyers. So this does affect central banks as well, especially central banks in countries that have problems. It does affect fiat currencies, because it's going to force banks to basically modernize. And so, again, all of these legal restrictions are going to get challenged, of course, which is going to probably make the banking system more open, and that's a good thing. But it can never be a cryptocurrency, and it can never be as open as Bitcoin or any of the other open, borderless, public, neutral, censorship-resistant cryptocurrencies. So I'll hold what I have, because to me this is not about convenience of payment. This is not about access to a 2 billion user base. This is about being able to be free to hold my own money, to not have anyone be able to freeze it, censor it, tell me who I can transact with, or when I can transact, or how I can transact, or what I can transact for. That freedom is at the core of cryptocurrency, and that freedom is the one thing that you can't do with this GlobalCoin. I hope you enjoyed yourself. This is the May live stream. I've answered as many questions as we have time for this time. The next one is going to be towards the end of June. I believe the date will be June 29th. You'll see an announcement. Don't forget, please do ask questions, post your questions online, vote, comment, make these great questions. Today was almost an entire session focused on privacy, which I had a lot of fun with. And again, thank you so much for watching live. Thank you so much for supporting me on Patreon and allowing me to do these things that I do. Upcoming, we've got a fantastic European tour. If you haven't heard about this or haven't been paying attention to the announcements, I'm going to be in Sofia, Bulgaria next week on the 31st of May, and that's the beginning of my tour that starts in Sofia, Bulgaria and continues in London, England, Edinburgh, Scotland, Sofia, Bulgaria, Berlin, Germany, London, England, Edinburgh, Scotland, Zurich in Switzerland, Hamburg in Germany, and not Hamburg, Munich. I made that mistake twice. All right, let's start this again. Are you ready? Okay. It starts in Sofia, Bulgaria, Berlin, Germany, London, England, Edinburgh, Scotland, Zurich, Switzerland, Munich, Germany, and ends in Athens, Greece. Every one of those cities, we're going to be doing multiple events. There's conferences like We Are Developers in Berlin. There's meetups and community events, as we're doing in Zurich and Munich, for example, that are either free to attend or very, very inexpensive, thanks to your support. Patreon is paying for this entire tour, with the exception of 1 or 2 commercial conferences. The vast majority of the events I'm doing are going to be free or very low cost to attend. I hope to see many of you. And don't forget, if you're a $10 or greater contributor, monthly subscriber on Patreon, you get to come to one of my happy hours. I'm going to be doing a happy hour in every single city where we have some food, we have some beers. Many of you who are on the chat room today have been to these. I hope to see you again. I'm coming to some of your hometowns. And it's not cheating if you decide to change your contribution for just 1 month and come to a happy hour. I'll be really, really glad to meet you there. Thank you so much for watching. Have a wonderful weekend. That's it for me.